Uh, Welcome to Friday. My name is Mr. Hayes, and I'm here all day. Uh, it's the Friday show. Uh, Listen, we did our warm up. We're going to do our last notes for Unit 9, and then we're going to practice. And I decided our test will be next Friday. So we're going to practice and review on Monday. We're going to practice and review on Wednesday, and then we're going to have a test on Friday. I think it'll be fine. All right, here we go. So our last section. Actually, and also just to let you know, I laid out the calendar for the rest of the semester. I mean, I don't have every day planned, but I make a map of it all. And after today, we have 23 more class meetings before our AP test, which is something like Wednesday, May 4th. We're in the first week, the second or third day of AP test. And I'm going to come to your house and I'm going to make you embarrassed in front of your family. Nothing.
Okay, but if I pass the test, what will that bring in my life?
Nothing.
Does it count for college credits for most colleges? No.
Actually, I don't know. So, in case you couldn't hear, people watching on video, someone who shall remain nameless said, "Does it matter if I pass or fail the test?" And I said, "It doesn't matter if you fail the test. If you pass the test, you might get college credit. If you were going to go on and study engineering, computer science, you don't want to try to pass out of, CS1 at your college. You need to just go ahead and take it and have it be an easy class because you need to learn what they want you to learn, at the college that you're going to. So I would recommend not skipping any classes, even if you get a 5 on this AP test, which is fine. It's great. Why not take have one of your freshman college classes not be hard? That'd be great. Anyway, it's not going to change your life, but you've learned a lot about computer programming, and that hopefully will help you down the line. I've had students say, "Hey, even though I'm not a computer science major, someone who was an econ major had to do a little bit of programming on a group project with other students, and everyone else was going like, 'Oh no, we have to program,' and this kid was like, 'Oh, check this out, I can do this, pop, 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 done.'" And so it might help you. Okay, 9.7, the object class, folks. You didn't know it, but everything in Java is a child of the object class. And it's apparent above all Java classes. And it's implicitly extended whenever you create a class, and don't use the extend keyword. So when you just make a scanner scan equals new scanner system in, it's inheriting things from the object class. And also when you create a string or an array list or anything, they're all inheriting from the object class. All classes are children of the object class. It's at the very top of the hierarchy, and I want to show you, I think this link will work. We'll take a look. Oh, I'm glad it worked. Here's not the latest version of Java, but we're on the Oracle website where Oracle owns Java. And here's the class called object, and it's got a constructor. You can create a new object. It wouldn't do much. But if you look at methods they have, there's a clone method. I've never used that, but here's dot equals, and there's one called get class that tells you what the name of the class is. We've never used that before. And toString returns a string representation. So we don't need to worry about all these things. But if you went to dot equals, it tells you what it does. And we've been using dot equals, right? So back to here, I'm going to cancel and then go back to the slideshow so it's full screen. We often will override toString, and we sometimes override dot equals in custom classes. So let's talk about toString. We've been writing toString methods in our custom classes. And remember, if you don't do that, you get that @ symbol with some letters and numbers. That's called a hash code. We've been overriding toString. That means writing a toString method in our own class for months now so that we can get pretty representations of our classes instead of the hash code symbol, which is useless. So all you need to know today about toString is if you want a custom class to print nicely, you have to write your own toString. And that's actually overriding, not overloading. It's overriding when it's the same name and signature and everything. No, like there's nothing in the parentheses. The only other object method we have to care about in this class is dot equals. And I just want to, I'm giving you a little overview. You've already learned about this. We use the double equal signs to check equality. Like if you're doing an if statement with primitives, like if this integer equals that integer, you use double equals. For reference variables, like string, you need to use dot equals. If you use the equal signs with objects, it's not going to work. So unless this is what you did. Look at this example. I made a frog A, and then I said frog B equals frog A. So what happens there is literally B isn't another frog. If you hop frog B, frog A got hopped also. They're the same frog. So if I print this out, A equals B, or if I said if A equal B, it's going to say true because they're literally the same frog. So you hop frog A and then say, where's the location of B? It'll be the same as A. Yeah. Oh, yeah. This code, A and B, it's just two different names for the same frog. Doesn't matter. Yeah, if they were both me and you punched me when I was A, I would say ow as B because it's the same. It's literally the same thing. They're actually, that's what reference variables are. They don't set up a whole thing in memory. They set up the whole thing in memory and then set up a pointer to that thing. So then when you pass that variable to a method, it doesn't pass that whole thing, all the data. It just passes the pointer, and then your method points to the original. And in this case, it pointed to the original. Here's how if you wanted to make two frogs, so frog A equals new frog B equals new frog. If I ran this code, we'd get a false because A is not equal to B. Sure, they're both frogs that have a location of 0 at this point. And you could say, well, that makes them kind of equal. They're not pointing to the same object. There's frog A over here, and there's frog B over here. And if you're asking Java, are these exactly the same thing? No, they're not. So really, bottom line, you're never supposed to use two equal signs when you're comparing objects. Only when you're comparing primitive data. So, and then specifically, we learned this with strings a long time ago. Java requires that we use dot equals to compare two strings. That's mostly where we've been using it. The string class has a dot equals method that takes care of this for us. In fact, the one in string overrides the one in object. The one in object is just like, are these literally the same place in memory? Okay, then the one in string is like, hey, is the contents of this the same as the contents of that? Yeah, then we're going to call them the same. So if you want to be able to tell if things are equal, you as a designer, the coder, get to decide what equal means. So I'm going to show you how I like the gold standard for the frog class. Here is the gold standard dot equals for a frog class. So we're going to go over each part in detail. I'm not going to make you write all these parts. I wanted you to see the gold standard. I am going to make you write all these parts like today, but then after today, I'm going to make it simpler. So this is a dot equals for a frog. And we're going to go line by line. So first, a dot equals accepts a generic object, not a frog. So normally you think, well, I'm sending a frog over to this dot equals to see if it's the same as my other frog. But you're basically casting the object you're sending to dot equals into a generic object. So you can do that with anything. You could say, I'm going to turn this into an object. And then now it's an object, not a frog. We don't normally do that, except here we do this. So now, this method called dot equals is receiving something we're calling obj. And first we're checking, hey, if obj is null, then we're going to return false because it's obviously not equal to this other frog if it's null. So, like if it got created but not instantiated. you made an array of frog objects but forgot to put a frog in each spot, and then you tried to compare one with another, it would say, hey, they're not equal. All right, and then the next line or two is checking if literally the name of the class is the same as the name of the class. So we're saying, hey, if the name of the class that's being that dot equals like frog A dot equals frog B, if the frog A is equal to the text version of frog B, if they're not the same, see there's a not in front. If they're not the same, we're going to return false. So those are the parts I'm asking you to do today, just so you once in your life wrote a perfect dot equals. But after today, we'll just do the next couple lines. So then now we're casting this generic object that got sent, and we're casting it to be a frog. Remember we casted things to be int with the parentheses int or double, or now we're casting this to be a frog. And that's because we want to get down and dirty and check the variables. I'm considering two frogs to be equal if their location variables are the same. I know that denies them any level of personality, but the frogs I've been having you play with in this class don't have any personality. So here we're saying, finally, I'm making this new frog called other out of the OBJ that got sent in. And then now I can check if other dot location is equal to this dot location, then I return true, because that means, hey, these frogs are equal. I'm considering them equal if they've jumped the same distance. And then after all that, I say return false, because if I get to the end, it means they weren't the same. This is saying the location variable in the first one. A dot equals B. No, we got rid of OBJ. We turned OBJ into a frog, and it's called other now. So we're saying other dot location. You don't actually need to use the word this over here, because if you just refer to the variable name, it's going to be in the class, in the object that the method's running in. So think about it. Let's call it A, frog A, and we're doing frog A dot equals frog B. So this is talking about the A location. And frog B came in as an object. We checked these things. Then frog B got turned into this one called other. And now we're talking about other dot location versus location. Amelia. It's to call a method, you don't have to say this. You could just call the method. Yeah, that's just calling the method. No, that's a variable. Remember the frog has private int location. It's just a variable. Yeah, this is the A in our example. A dot equals B. This is, you're saying, hey, this one. We've used this before. If you make a constructor and you use the same variable name inside of the constructor header, then you have to say this dot location equals location. And I recommend not doing that. I always like to do L for my location in the method or constructor, and then just say location equals L. But some people like to write it all out everywhere, and then you have to say this, meaning the private variable in this class. Well, we're only checking one variable here because there's only one variable to check if two frogs are equal. If you were checking the electric guitar class, you would be checking if the model is the same, the price is the same, and the number of pickups is the same. And if not, you'd say, no, they're not the same. But if it was, you'd say, yeah, we're good. Yes. You can't get the location if it's just an object. Yeah. You can't run the method. You can run the method get class because that's up in the object. That's one of the object class methods, get class. But these lines that are highlighted, this is where you have to think, okay, now I'm working with this specific class. If it's a student class, you're going to compare first and last names, and if it's uh, if it was uh, a book class, you'd compare title, author, and published date, that sort of thing. Um, Finally, at the very end, where you return false, if we got to that point, they're not equal, because primarily because this line wasn't true. So, uh, so this example shows all the key parts to a dot equals method. Checking if it's null, return false if it is. Make sure obj and the current object are the same class. If not, return false. Cast obj into the current class type, frog, student, book, whatever we're trying to write a dot equals for. And then check all the instance variables for equality. If they're all equal, then say true. Yeah, if they're equal. Otherwise, return false. So I have a frog class with dot equals in it, and I want you to play with it a little bit. I'm gonna open it up first, so just you can look what I'm talking about. I made a frog A and a frog B, and I'm saying, hey, are they equal? Should this return true?
No. Yeah. No.
Captured forever on the video, cussing.
Oh yeah.
Listen, if I said A equal B, we should get false because A and B don't point to the same literal place in memory where a frog variable happens to be created. So we're going to get a false and then a true. The reason A dot equals B is true is that I just decided frogs are the same if their location is the same location. So I'm going to get rid of that one. But watch this. If I hop frog B dot hop, I can't remember if this one wants a number or not. Yeah, it wants a number. B dot hop. I'm going to hop this one just ahead one. So now it's going to say false when I run a dot equals because they haven't hopped the same. They're not at the same location anymore. Also, if I say A dot equals null, I'm going to get false. It's not going to crash because it's checking. And if I say A dot equals howdy, a string, we should get false because that would check class types. Class type frog versus class type string. It's like, well, obviously they're not the same. They're not even the same class. Okay, so I said I promised you I would let you play with this, and I'm going to let you play with this for a few minutes. What's up?
It never checks if like A is null. Like let's put null dot.
Then you can't. Yeah, you have to. The one you're trying to compare with has to at least not be. You have to start with something. I mean, I don't know. I've never done it, but this is not comparing a frog anymore. But let's see. I'm posting this on the Google Classroom right now. Just and I want you to. I want you to open it and just play with it a little bit. It's just an example. There's nothing to turn in. So I will pause our recording. Let's wrap this up. Folks, you will not have to write a dot equals method for the AP test. You might need to show that you understand how it works, and you need to know that by default everything dot equals and toString and other things are all inherited by the object from the object class. So technically, just so you know, the bare minimum for our frog class, if we wanted to do a dot equals that just was lean and mean, this is all we would have to do. You still have to accept an object, not a frog, because that's how dot equals works. If you accepted a frog, that wouldn't be overwriting the dot equals command from from the object class. Um, so then you cast your incoming object into a frog and then check the location. That's the bare minimum. And that's assuming no one would ever call dot equals with a frog with something other than a frog. So, but I'm having you write the longer, better one today just for practice. So,
if you call the child, like in that one, in child class, like you think you all,
well, if we had a guitar dot equals and we tried to compare a guitar and an electric guitar, I think it probably wouldn't work. Because, but it might work. It might just ignore the number of pickups. And if the other stuff were true, were the same, then it'd say, yeah, it's good. So I don't know. We'd have to try that. Yes.
So if you had that and you tried to like compare two strings, would it work?
Inside, like internal string variables, you mean? Or?
Yeah, like say we have this like class like fraud something, and we have a sub equals into the fraud class. Could like in your main method, could you like separately compare two strings? Like say it's the string A, like the string
You can use dot equals inside of dot equals if you're asking that. Yeah. All right, rest of today. We're finished the warm up if you didn't. And then we have a light class where I'm asking you to write a dot equals. And then there's a light string class, which is unrelated to the light class assignment. So I know it has the same word light in it, but it's a totally different thing. And it doesn't use inheritance. So just be open-minded, and it's just an interesting assignment. And then AP Classroom, I'd like you to last today, not due till Monday when class starts. I want you to finish AP Classroom problems 11 through 18. So priority is the light class, write a dot equals that just is top of the line, gold standard. And then I want you to write the light string class, which is an interesting assignment I thought up 2 days ago. And then after that, do the AP Classroom. And this last part is due Monday before class starts.